Alright, in this video, we're going to take a look at three things. We're going to take a look at particle groups, pop replicate, and particle collisions. Okay, so to get started, I'll just create a simple geometry and I'll create a simple sphere, or I'll create two of them. Okay, so this one will be for collision, and then I'll create another sphere. I'll move it slightly above it, and we'll just scale it down. Okay, so we have these two things, and then I'll take a null. I'll call this out collide, and let's call this one as emit. So this is done. Let's also take this slightly above ground, so over here. So let's take a pop network and we'll connect both of these. So first we'll take a look at particle groups. Now there are a lot of different ways to make groups. Now there are a lot of things you can do with groups. We'll just take a look at some basic examples and some complex things that are not sort of easily apparent. So let's do one thing. Let's give it a force. So we'll just give it a pop force and we'll have it fall down. So I'll make it minus 0.3 and a little bit of noise. So let's press play and you have this. Okay, which is fine. And let's lower the lifespan to about 4. Okay, so let's say we want to create a group of these once they reach frame 48, okay, just for fun. So what I'll do is I'll create a color. I'll give these some color, okay, just like that's the default one, so let's keep it at that. Okay, and then what you do is you take a pop group. Now there are a lot of options within the group node. So just to sort of go through them, you have rule-based groups, which is you can write expressions. That's the one that you usually end up using. Let's give it a group name. So let's call it in, and turn on preserve group, so to sort of stay in that group. And we'll take another pop color and we'll color this, let's make it red or pink, and we'll say the group is in. And let's start with something like, say, bounding box. So I can create a bounding box and I can put it here, and then I can just say, okay, like when it comes in here, see, oh, sorry, it's not connected. Yeah, okay, so there was a problem there. Yeah, so there you go. Okay, let's make it a slightly darker color so it's easier to see. Yeah. So if you turn off preserve group, what happens is that only when it's inside that bounding box, it's getting the color. Okay, and the minute it leaves the bounding box, it goes back to the original group that it was a part of. Okay, so which is also an interesting thing that you can do. Okay. Now along with this, you have other options like you can random, so you can say 50%. Okay, so you see you're getting like 50% of them are, okay, or maybe like lesser. So there you go. So you can do that. Or then you can combine groups. So if you have multiple groups, you can combine them. So let's say what you can do is, like, once you've generated this group, I can come in here. I can probably take another pop force and the group is in, and let's make it positive. So we'll make it positive 0.5. So what should happen is, see, those guys start moving upwards. Or we can say something like, let's bypass that and let's say like those ones should slow down. So we can take a pop drag and I can slow down in, and let's increase the group to around 0.5. Yeah. So what will happen is, see, so those ones are slowing down and these ones are not. So this is what you can do with groups. Now, this is setting a group based on, like, the ready-made stuff you have. But you can also do groups based on expressions, okay, which gives you more flexibility. So let's say if I want this to come into a group at around frame 48 or frame 50. So I can just say at frame, okay, greater than 50. So what I can do is if I press play, sorry, turn off random, yeah. And at frame 50, they'll all come into one group, okay. Now this is not a good idea, we don't really want to do this. Okay, so what we can do instead is, okay, you can also sort of reverse this. So we can say frame sort of less than 50. Okay, so it will start off being slow and then it will speed up. And here again, you can see what happens when you turn on preserve group. So with preserve group off, you can see like at 48, they all, switch to the new group. But if you turn on preserve group, then the ones that were part of it, they remain in the slow. Okay, they remain with like the drag being affected to them, and the new ones being born come into, like leave that group. Okay, so you can do stuff like this, but then let's say if you want to select based on age. Okay, so what we can do is I can do something like at age is, let's say, greater than 1. Okay, so every particle, like let me turn on my geometry spreadsheet. So I'll just come into inspectors, geometry spreadsheet, and so the age is, so when the age goes over 1, see they'll start, coming into the new group. Okay, or let's say age of 2, 2 should be good enough. See, there you go. So when the age passes 2 for every particle, it comes into the new group. Now, what if you want to randomize the group? Okay, what if you want to say an age between, what's my lifespan here? 4. Okay, so let's say we want to say the age between 2 and 3. So what I can do is I can come into my pop group and I can say age greater than, and I can do fit01 random at ID, comma 2, comma 3. Okay, so you're taking the randomized ID and putting it between 2 and 3. And so what that will do is it will give you a larger range. See, so now you're getting a much larger, like a randomized range. See, so this gives you a much more, interesting thing to work with. Like another thing you can do is we can try to calculate the speed of my particles. So I can take a wrangle here, like before the group, and I can generate, let's say f at speed. So the speed formula is length of velocity. So just do length length of at v. Like that's the formula for speed. Okay, so we'll get an attribute called speed in here. So if we look for it, yeah, so there you go. So you have an attribute called speed. Okay, and let me just turn off the group for a second. So I'll just turn off these guys. Okay, so the fastest they're getting is something like 1.4 or 1.5, which is okay. So let's say what I can do now is I can come into the pop group and I can say something like, let's say we want to select the slow particles or the fast particles. So I can say at speed is greater than, we'll do the randomize itself, but we'll say 0.6 and 1. And this should give us like the fast particles. So we'll turn off the drag for a second just to see what we're getting. See. And then what we can do is now we're sort of affecting the fast particles and saying like whenever they go over a certain speed, they'll suddenly just slow down. See, so now all the fast particles suddenly slow down. Okay. So if we come into like the pop force and maybe like increase the magnitude and see, so none of the fast particles stay for too long, okay, because it keeps sort of catching them and slowing them down. All right, so to cover one more thing, which is what if you want to create multiple groups one after the other, which is like you want to calculate the time that a particle spends inside a group, and then once it's spent a certain amount of time, then it should move to another group. Okay, so something fancy like that. So let's say instead of the actual time, so let's say at 2 seconds it entered a group, and then once it's been in there for about another second, it should move to another group. So how do you do that? Like, how do you calculate something like that? In order to do that, you need to create another attribute. So what we'll do is, I'm going to take this particle group, and yeah, this is fine. Let this be. But what you want to do is we want a way to calculate the in-group time. Okay, so in order to do that, let's just say this group, okay, we'll again base it on age, and we'll say age is let's say 1 and 1.5. Okay, so we're getting particles going into this group at 1 and 1.5, which is good. Okay, and let's lower the drag so it moves a little bit. Yeah, okay. And now what we want is, now that they've entered this group, we want to start calculating the time that it is spending inside this group and then move on to the next one. So after the pop group over here, let's take a wrangle. This wrangle will affect in. And what you want to do is you want to create a new attribute. So we'll call it new age. So we'll say f at new age, and you get an attribute called time inc. So this is the attribute we'll be using. Okay, it's a ready-made, it's an inbuilt attribute. You just have to remember something: the T is capital and the I is capital, and we add this to the new age. Okay, so you say plus equal to and at time inc, so time incremental. And if we play this, let's find new age. Where is new age? Yeah, there you go. So what will happen is, see, new age is 0. At frame 24, they start entering the new group and the counter starts. So it's now calculating a new age for you once it is entering this new group. And then I can take another group and let's call it stop. And we'll enable this, and I'll say at new age is greater than 1. So once it's spent about a second inside the new group is when it should enter our stop. And then we'll take a color, and this is stop, and we'll just make it red. See, there you go. Let's make this slightly brighter, and we'll turn the background dark. Yeah. So what's happening is, see, once it comes out, and then I can apply another drag to stop, and let's increase this really high. See. And so you can do this multiple times. Like, you can create new age 1, new age 2, new age 3, new age 4, and just keep adding the time incremental to them. And if you want to move from one group to another based on time that has been spent in the group, this is a nice way to do it. All right, so this is done. Like, this is as far as, the basics of groups is concerned. Now let's take a look at particle collision. Okay, so we can use this itself. Okay, let's do one thing. Let's just, let's create another pop network. So let's take another pop network, and I'll just connect these two guys here. Yeah, and let's jump in. So let's do the same thing again. I'll just take a pop force. We'll have it fall down. So minus 0.5, a little bit of noise. Okay, and so this is falling down, which is good. And there are two ways to do collisions. Okay, one is you do actual sort of rigid body standard collisions, which is needed if you want the particles to bounce. Okay, but if you don't want them to bounce, then there is an inbuilt node at particle level called pop collision detect. Okay, so that's the one that we'll use for now, but I'll show you the other one as well. So let's just give it a color, okay, just for fun. Okay, so the way it works is type in collision and you'll find pop collision detect. Okay, so just drop that in, and we want the second context geometry. So there you go. So you can see something happening in there. And by default, it won't do anything. It'll just detect a collision. See, so when it goes through, it just sort of, detects it. And in behavior, you have certain options, like you can say, so you can say accumulate hits. So it kind of just, otherwise it doesn't really pick up the color, like it's moving into it. See, there you go. So when it hits that, it sort of changes color. But you can do multiple things with this. Like the most basic is you have an option called response, and you can change that to die. So when it hits, it will just die. Okay, so you can do that. You can do stop. So they'll just stop. See, so they just fall there and they stop. Or you can have it stick, which is pretty much the same thing. Okay. Unless you have like gravity or something, then it'll, try and slide over it. So you can try to do that. Like let's try adding gravity over here, like at the end. And let's see if that has an effect. Yeah, not really. Okay. Okay, and then we can also do slide. Slide is nice. So slide gives you like, see, it just sort of slides across. And you can also give it a group, like I can say a group and we'll call it hit. Okay, and let's say preserve group. And then I can take a color. So let's say we take a pop color and I'll say color hit. Yeah, there you go. So these are all the particles that have hit, the sphere, which is almost all of them. And let's make this slightly higher. Yeah, and then let's say if we want a second collision, so we can, let's say if I pick up a grid and then we'll connect the grid here. So I can take another collision. So I can take pop collision detect, and let's do third context geometry and slide. And what should happen is when it comes to the ground level, see, it does that. And we can create a group for this as well. So let's call it ground, and we'll again give it a color. So and then let's give it a drag. So we'll say pop drag, and it slows down when it hits the ground. So what we should get is when it hits the ground, see, it starts to slow down. And I think the life is too long, which is why it's not dying at all. Yeah, okay. So let's just make the life down to around 6. I think 6 should be fine. Now, if you want to actually generate like particle hits which sort of bounce, then you can actually do it using the static solver, which is used in your rigid bodies. So what I can do is, let's say if I take another pop network, and I'll just connect this, and we'll connect that. And then what I can do is, I can again create this source. So I have my particles, yeah. And then let's give it a let's just do one thing. We'll just give it a gravity. So I can just come down here and type in gravity, and you'll get something called gravity force. Okay. And then in order for it to actually collide with something, you can take a static object. So just take a static object and we'll pick up the out collide and then merge these together. So just take a merge here. Yeah, and if you don't want to see it, you can turn off the display geometry. So if you press play, you'll get this. See, so it bounces off it. Okay, which the pop collision detect won't do that. And so you can define like the bounce amount, and then if you want to slow it down, you can lower the bounce forward, and then that will sort of it will sort of slow it down a fair bit, and then it falls, which actually looks pretty nice. Okay, like you can increase the bounce forward and it will be a little bit faster, see. Or you can like make the bounce 0, which is also fine. Then it will just sort of slide across it. And then let's say if you want like a ground hit, then you can take a ground plane. Okay, so that is also a nice idea. So you can just take a ground plane and we can merge these two together. So you don't need to take a static solver, like just taking this much is enough. Okay, and then we can just play it and see. And here again we can do the same thing. So I can lower the bounce and lower the bounce forward. Let's just give it some color. Yeah, let's do a ramp. I think a ramp is a good idea. Okay, now the edge is too long, which is why it's not coming in. So let's just lower it down. Yeah, okay. And let's make it, let's make it like blue or something. And let's turn off display geometry. There you go. Okay. And then we can also add like some basic force here. So a little bit of randomization is always a nice idea. Yeah, there you go. That looks better. Yeah, okay, like this is like getting too much bounce on it, which doesn't look bad actually. But yeah, there you go. Okay, so this is nice. You get a decent little water effect if you want. So yeah, so this is how you can use the basic static object solver to calculate collisions. Now, one thing that we can do is because it generates groups, you can also do other things when it hits something. So let's say if you want, like when it hits, it kind of generates a spark or something. So we'll do like another example for that. So what I can do is, so we'll create one more pop network, and what we're going to take a look at is something called as pop replicate, which is you can generate particles from particles. So if you're coming from like a max background, it's like you're spawning particles. So let's do the same thing. This is the emit and the collide. And what I want is, I just want to generate very few particles. So I just want to generate something like, and let's do 50. Yeah. And we'll do a pop force. So let it fall down. Let's do -2. And then I'll do a pop collision detect. We'll do second context and let it play. Yeah, okay, so this is good. And then what we want is it should die when it hits it. Yeah, okay. Or let's say for now, instead of dying, let's say it stops when it hits it. So they just kind of stop. And then what I can do is, let's create a group out of this. So we'll call it stop. And then you get, so you've used the pop collision detect to generate a group. So there's a group called stop. And then I can simply just do a pop replicate, and by default it will start emitting from everything, which is not what we want. Okay, and the default emission shape is kept to a sphere. So we'll just make a small sphere. Okay, and then this should emit from stop. So what will happen is, see, when it comes down here, see, it emits particles. What you can also do is you can say kill original particle. So it will just, kill the original particle, and I can give it a very short lifespan. See, so they'll die out. And then I can just simply give this like a force or something. So I can just, like, I can come to the pop replicate and I can do set initial velocity. So these will sort of, like it's inheriting from that. So let's do one thing. Let's just get rid of that. Yeah. So what happens is, because those particles had stopped, this cannot move. So don't let it inherit anything from the previous one, like if you don't want it to. Okay, but there you go. See, so now you're getting like these explosions. We can just inherit the color. Let's just inherit the color. Okay. So we'll get this, okay, which is not bad. This is interesting. And then I can take, let's just emit from a point. Okay, like, because this is a little too much. So yeah. And again, the life can be down to 0.5. Yeah, there you go. So that's how you can, and then we can give it a color. So this will generate a new group on its own, like the pop replicate will generate a new group, okay, based on the stream. So this is, it'll generate a group called pop replicate 1. We can call it something like, say, explode. So it'll generate a group called explode, and I can set this to, I don't know, let's try yellow. And maybe we can lower the birth rate to about 10. And we can try something interesting. Like, so I can come in here and let's have it bounce upwards. So we'll do about 0.7. So they'll move up like that. Okay, hold on. It's not, yeah. Sometimes it doesn't reset the simulation. Yeah, okay, that's too much. See, the problem that's happening is changing the velocity is not resetting the simulation. Changing like a physical value over here sort of resets it for some reason, like there's a bug in there. Okay. We'll increase the life a little bit. Yeah, and then what I can do is I can take another, let's take another pop collision. This will affect explode, and same thing, like second context geometry. And then I'll take another pop force and have it fall down. So give it like slightly negative, and yeah, this will also affect explode. Okay, let's see what we get. See, so you're getting this. Okay, but it's also going to hit this, hit the geometry over here. So we'll set that to slide. Okay, so what should happen is, see, they're doing this. They're sliding over, like we won't color it. See, so this is interesting. And if you want, you can see this as lines, which makes it look a little more interesting. See. Yeah, so that is pop replicate. And you have a bunch of options in there. Like mostly this is what you need, but a majority of the options you have are mostly like shape based. Okay, so what you can do is, the one thing you need to remember is you have to kill the original particle. If you don't kill it, because the particle is going to stop there, it will keep emitting from that point, which is not what you want. Okay, like if you want that, that's fine. But usually you want to kill that original particle so that it just gives you like this one burst. And then you have options here, like you can have it emit from a box. So the emitter will be a big box, okay, which is okay. Or then you can have a sphere or a cylinder. You have a bunch of shapes. Okay. You can have a grid, okay, or you can have a circle. Let me just increase that size. See, so you're getting like this big circle that it is emitting from. Okay. So you have different options, but they look weird because they don't emit from that original point. They emit from a circle around that point. So it doesn't, I don't particularly like it. Okay. It can be useful in certain scenarios. And what I can do is with the color, I can just set it to a ramp. Okay, so we can start off let's try to start off at yellow. Yeah, switch it over. The lines don't actually color. So it's just like if you keep it at point, then you'll see it. See, so now it's sort of fading off to black. And what we can do is we can try to give it like a really bright spot here. So let's try to keep it at 5. Like get like an initial really bright explosion over there. See, and then it sort of fades out. Yeah, so this is how we can generate, sparks if we want. Okay, so that's pretty much it. So this is covering particle groups and collision and pop replicate. So the next lesson we'll continue from here, and we're going to take a look at how to use collisions and replication to generate shock waves. Okay, so that's what we'll take a look at in the next video.